This is lecture 9 of the course on behavioral economics, and in lecture 9 we are going to discuss the standard model in neoclassical economics. Basically, with this we are beginning say the second topic going to talk about values, preferences, judgments, alternatively on heuristics, biases, etc. So, before we talk about why do we need to understand heuristics, biases and all, it is important to understand that what are the basic premises of standard model in neoclassical economics, or what the neoclassical tradition actually offer us, against which we are going to build up several other theories. So, we need to talk about violations, and before we talk about violations, we need to focus on the specifics of the neoclassical tradition. So, standard economic model is basically something that posits that individuals are rational, self-interested and utility maximizing agents with complete information, consistent preferences and perfect foresight. So, this part we have already discussed, we call these kind of individuals econs. Now, we get into the details of what actually the standard model of economics assumes in order to define an econ. So, we begin with the key assumptions. First of all, rationality. We have already talked about it. Individuals make decisions based on a logical and consistent evaluation of costs and benefits. Then it assumes that individuals are driven by self-interest. So, they primarily act to maximize their own personal gain or utility. The next one is utility maximization. The neoclassical tradition always assumes that individuals strive to achieve the highest possible level of satisfaction or well-being from their choices. Further, we assume that there is complete information, which implies that individuals have access to all the relevant information about prices, products and potential outcomes. So, it is not only always about prices, products and potential outcomes. Generally, any economic model would assume that both the parties or all the parties involved have perfect information. If there is not perfect information, which is most often the case around us, then we have this problem of information asymmetry. So, economists have also worked on the concept of information asymmetry, but for most part we assume that information is perfectly available with all the parties involved in most transactions. Then we assume consistent preferences. Individuals have well defined and consistent preferences, which implies that their choices are logical and predictable, pretty much similar to the assumption of rationality. Basically, all of them together imply that individual decision makers are rational. Individuals also have perfect foresight, which implies that they can accurately predict future outcomes and make decisions based on their predictions. The most accepted mathematical model is the augmented neoclassical model. Now, we will be considering a stylized version of the standard model with three components of rationality. The expression of the neoclassical model, which we in short write as NM, in mathematical terms enables us to achieve three important objectives, and they are, first of all, a concise description of the relevant factors affecting decision making. Number 2, an illustration of the various components of the model that can be examined, and number 3, a general consideration of the assumptions underlying the model in terms of how they relate to the various components. So, as you can see that neoclassical modeling techniques are extremely systematic, and that is why probably they have been favorite of the economists. You can go very mathematically, very systematically. For that you may need to use certain assumptions. Nevertheless, that systematization is actually extremely attractive. Now, the model can be stated in the following terms. We are now going to define a model, and to begin with we use or explain some notations. So, an individual I at time t equals to 0, which most often refers to the present time, maximizes expected utility subject to a probability distribution of the states of the world, where small s belongs to capital S. So, this S consists of all possible states and small s refers to a single state. P refers to the probability associated with the single state. Now, we will be giving examples of that, but then you can consider many different situations around us where we basically have alternatives and there are certain uncertainties associated with them, what is going to happen in future, and accordingly we can take a call. So, for example, for a student one needs to allocate study time to different subjects. You can always associate probabilities with your performance in the exam. So, different states would be your different performances in different subjects, associate probabilities with them. Some subjects you do not like much, so even if you study hard, maybe you do not understand much, you do not like it much, or you may not perform well in those subjects. The probability of scoring high is much low as compared to those subjects in which you have an expertise, you like them, you enjoy studying them, and that is why the probability of scoring high is also high. So, different states have different probabilities. Now, you need to understand how much time, or you want to calculate how much time you would like to devote for individual subjects. So, the possible scores or the probability of getting a particular score in a subject multiplied by that score, and then in a similar fashion I can have the probability of different subjects and the probability and the scores in those subjects, all added them together is going to give me the total utility. I can try to solve them in order to find out how much time I am going to devote to individual subject. So, this is how we write it. We are going to maximize basically a stream of utility with each output subject to a particular state. There is certain probability associated with it. We tend to discount the future events, and that is why a discount rate is associated here or given here. See, here in this case everything is going to happen in future, but it is possible that something is going to happen today, something is going to happen tomorrow, something is going to happen day after tomorrow. So, there is a stream of utility forthcoming. You need to decide how to maximize your utility by choosing, say, the level of consumption in different time periods. So, accordingly there could be discount rates associated with future consumption. I previously mentioned that discount rates are like we do not equally value present and future. So, something which is coming in future is valued less as compared to something that is here at present. Very simple examples are, I have 100 rupees today. If I want to lend it to someone else, I would be expecting an interest rate. Why is it so? Because when I lend it out, then it implies that I am foregoing my present consumption. So, I need a reward for them or reward for this compromise or sacrifice, as a result of which what is 100 rupees to me today, 100 rupees is actually not equal to tomorrow's 100 rupees. Tomorrow, since I compromised it today, I need something larger tomorrow. So, tomorrow I could be happy with not 110, not 100 rupees, but say rather 110 rupees. Alternatively, if I ask someone that I want to give you some money either today or say 30 days after today. So, you can take 100 rupees today and or you can take 110 rupees after 30 days. So, on the 30th day, which one you would prefer? If somebody says that I want 100 rupees today instead of 110 rupees after 30 days, which means he or she discounts the future. 110 rupees after 30 days is not equal to 100 rupees. Of course, understandably 100 rupees today will also not be equal to 100 rupees on 30th day, right. So, since these valuations are different, so we say that future is discounted and we are basically summing them up, the future stream of consumptions, future streams multiplied by the probability of their occurrences, and then we maximize that sum. This is a standard exposition of the augmented neoclassical model. The utility function u x given S is defined over the pay of x I t, that is individual i's outcome or consumption at time t is given as xit. So, it is mentioned here pay of xit of individual I and future utilities discounted with a time consistent discount factor which is delta. Now, time consistent discount factor is very specific to neoclassical model, but we will talk about it much later when we discuss intertemporal choice models. So, for the time being we just talk about a discount factor which is denoted by delta. Now, let us break the model into 4 components. The first one is we are maximizing, where we are choosing the possible output xit which belongs to x, which consists of all possible xit's. Then we have the second component which is the summation of the discount factor t running from 0 to infinity. So, for t equals to 0 we do not have any discount at the time. At present our delta raised to the power 0 is equal to 1. From next time onwards period 1 will be having delta equals to discount is equal to delta 1, period 1 discount will be delta. So, at t equals to 1, at t equals to 2 will be having delta square and so on. Then we have this probabilities summed up, and that is basically for each state we have a probability individual state belongs to the set of all the states at time period t, and finally the fourth component is the summation of all the utilities. The main assumption underlying the neoclassical model can now be stated in terms of how they relate to these components. First of all, economic agents are rational, that is reflected in all the components 1, 2, 3, 4. Economic agents are maximizing, they are into optimization problem, they are maximizing sum of possible utilities. Then they are using consistent discount factor. So, that is also one characteristic of rationality. They can predict the future reasonably well. So, have probabilities associated with each and every outcome that are possible, and then finally very clear idea about the stream of utility. Economic agents are motivated by expected utility maximization. Again they are going for maximization, this is the expected thing and this is utility. I have reproduced the equation at the top. So, further an agent's utility is governed by purely selfish concerns in the narrow sense that it does not take into consideration the utility of others. So, as you can see that when we talk about individual's utility, individual I's utility, it actually concerns itself about that individual only. The utility generated by the consumption of other individuals are not coming into picture here, which might not be the case always. I may get certain pleasure by donating some money. In that case, consumption by others are also adding to my utility. Yesterday or in the last lecture we talked about the vicarious consumption of Veblen. Here he talked about what kind of pleasure the family head gets when he sees that his family members are enjoying luxury. They are, in case of rich people, even the rich people is actually earning money, or the person, the family head is earning money, the other family members are also enjoying. So, that is vicarious consumption. Similarly, even for middle class individuals, when they see that he is able to, or an individual is able to arrange money for his family, he gets some pleasure. So, it is not that we get pleasure out of only our own consumption, we get pleasure from the consumption of others as well, but that is not considered in the neoclassical framework. Agents are Bayesian probability operators. So, we have these probabilities here. Agents have consistent time preferences according to the discounted utility model. I repeat, discounted utility model we are going to talk about much later while discussing intertemporal choice models. All income and assets are completely fungible. Fungibility is again one concept we will talk at length, or we will focus on while discussing the concept of mental accounting. For the time being, fungibility implies that money does not have any labels associated with it. So, it is not that the salary that I receive in the beginning of the month or at the end of the month does not have any specification about this much should be spent on food, this much should be spent on children's education, this much should be saved and things like that. So, the idea is that the entire amount can be spent on any possible goods and services as wished by me, which apparently sounds perfectly fine. This is how we of course look at money, but when it comes to our behavior, we will discuss later that this is not true. We often violate the assumption of fungibility. Now, let us take an example of the neoclassical model. Suppose a student is going to attend a lecture or a course on behavioral economics. Now, he does not have any idea about much idea about how the course is going to be. Now, the state of the world are the course can be interesting, the course can be boring. He develops certain probability or Bayesian priors by consulting seniors and get to know that the probability that the course will be or the class will be interesting is 0.8 and there is 20% chance that the class will be boring. Now, the class is in the morning and before going for the class he has two options, either he can drink coffee or he can drink beer. So, now we have the situation, this is the decision one needs to make. So, we can call it I taking two values whether to drink coffee or to beer. The state of the world, so S has again two states alternative interesting and boring. Probabilities are as we were denoting them by PSI. So, probability of the class being interesting is 80%, the class being boring is 20%, and this is the payoff. So, this is the expected utility associated with each and every decision. So, along with the state, so Xi given the state Si or we can write it Sj. So, what is happening here is that if the class is interesting, then he expects a payoff of 10 provided he drank coffee before coming to the class, because coffee keeps you awake. Class interesting, you have taken coffee, so now you are able to concentrate better, as a result of which you have high utility at 10. The problem is that if you have taken coffee and the class turns out to be boring, then you are not able to even sleep off during the class. So, that is a lot of trouble and that is why you have the lowest possible utility from such a situation. Say you perceive, these are again individual perception, this may vary from individual to individual. So, one individual perceives that the payoff would be as low as 2. Now, in case you have taken beer in the morning and the class turns out to be interesting, then what happens is that you are not able to focus much. So, as a result of which your utility is actually somewhat low. You get a payoff of 6. The class is interesting, that is why you have a slightly higher payoff, but since you are not able to focus, that reduces your payoff. And if the class is boring and you had taken beer, then of course, it is a pretty good situation. You do not like it much because the class is boring, that disappoints you, that reduces your utility, but since you are able to sleep off during the class, that adds to your utility. So, you can expect a payoff of 4. These are all hypothetical numbers and I repeat that these are subjective evaluations that may vary from individual to individual. Now, having said that, what we understand is that what is my expected utility from the two situations. So, in this situation I will be having, if I drink coffee, then I will be having 0.8 multiplied by 10 plus 0.2 multiplied by 2. So, which implies I will be having an utility of 8.4. In a similar fashion, if I drink coffee, then from this like 0.8 multiplied by 6 into plus 0.2 multiplied by 4 is going to give me something like I think 5.6. So, since 5.6 is 8.4, given the information you decide to drink coffee before going to the class. So, neoclassicals say that individuals may make decisions in this way. Therefore, the optimal decision which maximizes expected utility depends on the probability estimates of the state of the world. The student should verify that the expected payoff or utility of drinking coffee is 8.4 while the expected utility of drinking beer is 5.6. Thus, the best decision in this situation is to drink coffee. However, if the probabilities were reversed, in the sense if the probability that the class would be a good one is just 20% or 0.2, then the optimal decision would be to drink beer, or we can recalculate given the information. We can see from this example that the estimation of Bayesian prior probabilities has an important effect on decision making. Bayesian prior probabilities are the probabilities that are assigned to individual states. The rational person will update these in the light of new information, so that if the class turns out to be boring, this will reduce the estimated probability of the next class being interesting and may affect the students' drink decision next time round. So, this is what is called discovered preference hypothesis. This was suggested by Plot in 1966. The standard economic model is a good predictor if people have had ample opportunity to learn from experience. So, Plot said that one can always discover preferences over repeated trials. So, in the first day of the class, if actually my expectation does not commensurate with reality, then in the next class I go and update it further, and so after several classes I may finally understand that the class is actually interesting or boring, or what are the probabilities of the class being interesting or boring, and accordingly whether I should drink coffee or beer. But of course, there are certain situations where we cannot have repeated trials. For example, people generally get married only once, then there are several other decisions. You retire only once. So, certain decisions actually come to your life only once and they cannot be repeated. In that case, discovered preference hypothesis may not be applicable. Now, talking about the decision making process, let us understand decision making by examining the process involved in most decisions. Of course, some decisions do not really appear to be decisions at all, because we act on instinct without conscious thought. This is often because there is no time for using the cold analytical cognitive system. Instead, we rely on the hot affective system, which is often dependent on instantaneous emotional or visceral responses to a situation. For example, duck an object flying at our head, or lash out in anger physically or verbally at someone who has offended us. So, there are certain reactions which are very much automatic. We call them, they are the reactions at hot state. So, basically when we are not able to process things properly. However, even in cases where this hot system is used and we are not aware of making a conscious decision, there is still a situation where some kind of stimulus results in an action. Whenever this situation arises, we deem them a decision making process is involved. What is needed therefore is a general model of the decision making process that applies to automatically reaching for the Oreo cookies at the supermarket, deciding where to buy a lottery ticket, investing in a particular stock, or choosing a particular medical treatment. So, decision making processes also entail certain automatic reactions, right. So, maybe we need to understand both situations. When we are making decisions by thinking about it or thinking over it several times, then the decisions are supposed to be highly rational. We cannot question them, but the decisions which are taken out of our natural reflexes or automatically, the automatic part of our brain, when it gets activated and accordingly certain reactions come, certain decisions come, they are probably of more interest to us, that how people behave in such situations and whether we then conform to the assumptions of neoclassical understanding. Obviously, these decisions are very different in nature and involve different factors and even decision systems, but there are certain elements that are common. There are three fundamental characteristics of decision making. These are described below along with their corresponding components in the neoclassical model as expressed previously. So, first of all, I rewrite that components of the neoclassical model. The first component of the decision making process is preference. These are the rankings people have over a set of options or gambles that are based on attitudes and values related to the outcomes of these options. That refers to component 4. Number 2 is beliefs. These relate to the probabilities with which people think various outcomes will occur conditional on available information. So, as you understand, that refers to component 3. Then we have rationality. This involves all 4 components of the standard model, referring to the ways in which people first of all determine preferences based on attitudes and values. So, component 4. Basically, our utilities are dependent on our attitude and values, the value we associate with different outcomes. or different situations, states, etc. Appropriately modify their beliefs in the light of new information. So, this is component 3. Discount values of future outcomes, we are talking about component 2, and succeed in choosing optimal action given their preferences and beliefs. So, given all this information, how we choose the optimal action by maximizing or following maximization principle. It should be noted that there is significant interdependence and overlap between these three categories. Belief affect preferences, and both of these affect choices as reflected in decision making. The beliefs, preferences, rationality classification is useful in that the factors within each category are involved at different stages of the decision making process. In a comprehensive survey of empirical findings in the field related to behavioral economics, De La Vigna examined deviations from the neoclassical model according to the above classification. He refers to these deviations as non-standard preferences, non-standard beliefs and non-standard decision making. So, the deviations have been there, but as I told you in the beginning that this topic broadly covers several modules on the deviations, but before we discuss the deviations we need to know about some important approaches and tools that the neoclassicals use. The standard model can be easily translated into a neoclassical model of consumer behavior. So, now let us become a more specific. The previous approach or the model is the broadest possible one representing neoclassical thoughts, but we can have different modeling structures for different segments or different problems. So, talking about consumer behavior, first of all, the objects of consumer choice are referred to as consumption bundles, consist of a complete list of the goods and services that are being considered. In a generalized situation, the context also matters. For example, people care future availability of goods and services. One would care more for a bottle of water in the middle of a desert rather than in the Antarctic. So, basically our preferences or choices are heavily influenced by various factors including time, context, etc. Most often we may not talk about it, and we are rather going for a generalized version of the behavior, consumer behavior that we would get to see around us. So, now I talk about some terminologies and notations. Any bundle of goods x can be described in the simplest term as x equals to x1, x2, where x1 denotes the amount of one good and x2 the amount of another good. Now, this bundle consists of only two commodities, but this bundle can be extended to as many number of commodities as possible. For example, we can write x is equal to x1, x2 up to xn, but generally we use two commodities because it facilitates use of graphical representation and analysis. In the neoclassical model, it is assumed that consumers can rank bundles according to their desirability. If a consumer definitely wants an X bundle rather than a Y bundle, then it is said that he or she strictly prefers the X bundle to the Y bundle, and this is denoted by X1, X2 preferred to Y1, Y2. Alternatively, if a consumer is indifferent between the two bundles, this means that they have no preference for either bundle over the other. This relationship is usually described like x1, x2, then we use this sign in order to indicate indifference y1, y2. Finally, if a consumer prefers or is indifferent between the two bundles, we say that he or she weakly prefers x1, x2 to y1, y2, and this is the notation that is being generally used, which is similar to the greater than equal to sign, but most often it has a curvature. So, this is how we might write as preferred to. Preference relations are meant to be operational notions. This is also assumed in the neoclassical model that choice is determined by preference. This is important since it is choice that is directly observable, not preference. And accordingly, we have this theory of revealed preference, which says that if a consumer chooses a particular bundle, it is assumed that this bundle is preferred to another bundle if that other bundle was both available and affordable. So, the bundle was available for purchase and the consumer had the money to buy that bundle as well. So, this is what is meant by the concept of revealed preference. Revealed preference results basically in the choice. The choices are observed, we purchase them and otherwise if choices are not made, then preferences will also not be revealed. The theory of consumer choice is often illustrated using a graphical approach involving indifference curves. An indifference curve represents different combinations of two goods between which the consumer is indifferent, that is, which yield the same total utility. So, this is how the indifference curves look. Those who are having background in economics, they would be very much familiar with indifference curves. For those who are non-initiated, I will just briefly say that these curves are downward sloping, as you understand that along an individual indifference curve, say I1, level of utility is constant. So, what is happening is that this is one combination point where the individual is say consuming y naught and x naught. Now, if I increase the amount of x naught or consumption of x from x naught to x 1, then of course utility increases, that is dependent on some of the assumptions. We will be talking about them later, but what we broadly assume is that I am getting more of one commodity, so I must be better off. When the moment I am better off, then my utility increases. The 2 points where only the amount of x is increasing, holding the amount of y constant, cannot be on the same indifference curve. So, in order to increase x, I have to reduce the amount of y. When I reduce the amount of y, then it is possible that I have another point where the utility is same. Now, by how much I will be reducing the amount of y, that certainly depends on the slope of the indifference curve. If the curves are very much flatter, then this implies that I do not need to reduce y much in order to increase x. So, I am increasing x in much larger proportion, reducing y by smaller proportion. Alternatively, if my indifference curves are very steep, then this implies that when this is my initial consumption, if I increase the amount of x, then I have to reduce the amount of y more than proportionately. So, how much I am reducing y in order to maintain same level of x, that certainly depends on the slope of the indifference curves, and they are dictated by the choices of individual consumers. This indifference map is showing a number of indifference curves with curves farther away from the origin representing bundles involving greater quantities of goods. These bundles are therefore preferred to those on lower indifference curves. Simply speaking, higher indifference curves gives higher level of utility, which means that the utility associated with I1 is less than the utility associated with I2, and utility associated with I3, the indifference curve, is actually the highest. Thus, any combination of goods on curve I2 is preferred to any combination on curve I1. Indifference curves are normally drawn as downward sloping and they are convex to the origin. So, why they are normally downward sloping, that I just discussed in the previous slide, and they are convex to the origin. It has certain implications also, but it is not mandatory for them to be convex to the origin. Indifference curve maps can be used to illustrate the notion of consumer equilibrium. It is assumed that consumers have a budget constraint relating to the amount of money that they have available to spend on the relevant consumption bundles. This budget constraint can be represented in terms of the following inequality, where Px is the price of x multiplied by the amount of x consumed, Py is the price of y multiplied by y, basically the amount of y consumed, and that should be less than equal to the total money available M to be spent on these two commodities. So, this is how a budget constraint looks like. The maximum amount that I can spend on commodity x is M upon Px, the maximum amount I can spend on commodity y is M upon Py. In between, I can spend any amount on both the commodities. So, here I am using y naught, or I am purchasing y naught and x naught. Here I am purchasing y1 and x1. So, these are various combinations which can be purchased using the same amount of money. Any point within the budget constraint implies that the budget is not fully utilized. I am purchasing some amount of y and some amount of x. When they are added together, they would be strictly less than M. This is indifference curves equilibrium graphically. So, what we are doing is that we initially gave a set of indifference curve. Now, this is a budget constraint. I superimpose the set of indifference curves on the budget constraint and we arrive at equilibrium here. Why? Because let us consider one point A. I have already mentioned that I1 is less preferred to I2, which is less preferred to I3. Higher indifference curves gives higher level of utility. Utility increases, right, as we move up. So, from point A, by consuming less of y and more of x, the consumer can reach a point C. Similarly, from point B, by consuming less of x and more of y, the consumer can actually again reach point C. Now, see that any point above C would lie on another indifference curve, so giving higher level of utility, but that point is not attainable given that the consumer has a budget constraint of m. So, C is the tangency point which gives us the maximum possible utility or maximum attainable utility from two different commodities. We will be consuming x1 and y1. By consuming x1 and y1 commodities at the given prices, we are basically maximizing utility. So, formally, although the budget is sufficient to buy combinations A and B, so combinations A and B, these are not optimal combinations since they are not on the highest indifference curve that can be reached. Combination C is the optimal combination where the consumer purchases bundles x1 and y1. This situation can be generalized. Any optimal point of consumption will occur at a point of tangency between an indifference curve and the budget line. Setting the slopes of these two curves equal gives the condition that the consumer should spend so that the marginal utility of the last dollar spent on each good is the same. This condition can be further generalized to apply to any number of goods in a consumption bundle. The mathematics associated with it, we may do it later. The exposition of consumer equilibrium in the neoclassical model often uses the term marginal utility, but in fact this is not essential. The slope of an indifference curve can also be expressed in terms of the marginal rate of substitution of one good for another. The MRS xy represents the amount of y that a consumer is prepared to give up in order to get one more unit of x. Thus, the equilibrium condition amounts to consuming a combination such that the MRS is equal to the ratio of the prices, that is MRS xy equals to Px upon Py. However, the interesting part is that MRS xy is also equal to marginal utility from x divided by marginal utility of y. So, they essentially boil down to the same thing. However, the advantage of this form of exposition is that it avoids the thorny concept of utility. With this, I close this topic or the module. Thank you so much.